This is Advanced Math, Unit 12, Lesson 6. Word problems. First piece we're going to do is quickly do some review problems of solving, because these type of problems come up on the test and kids always struggle with what method to use. So numbers 1 together. 1 is x to the 2/3 equals 19 versus number 2 is 2/3 raised to the x equals 7. Okay, so do you see how they both have a 2/3, they both have an x, they kind of look the same, but this x is a base and this x is an exponent. You do treat them differently when they look like this. X as a base versus x as the exponent, you solve them differently. When x is the base, you're just trying to get x by itself, so you raise both sides to the reciprocal power. 3/2, 3/2, gone and gone. You will need a calculator, so if you don't have one, hit pause, go and grab it. And you plug in 19 raised to the 3/2 power. 19 raised to the, use your fraction key, 3 fraction 2. If you're using your division key, you will need parentheses. If you can see it, but you know what it should look like. 19 raised to the 3/2. Again, fraction key, if you're going to use division key, you need parentheses around the 3 and the 2. And we're going to write that as 82.819. Okay, when x is the exponent, you do treat it differently. I can't raise both sides to 1 over x. That's not going to help me. I'm trying to get the exponent down as a base. I don't want it as an exponent, because if I'm solving for x, can't do it when it's there. So when x is at the exponent, this is where you take the log of both sides. You're not multiplying by log, you're taking the log of both sides. And it's log base 10 that we typically use, so I don't have to write the base. Log of 2/3 raised to the x equals log of 7. And if you remember from previous lessons, the whole reason we do this is to bring that exponent down to the coefficient. That was one of our log laws. X times log of 2/3 equals log of 7. All right, and then we divide both sides by log of 2/3. That's gone, and this is just a decimal hiding in your calculator. You plug it in and you get your answer. Log of 7, close parentheses, divide log of 2 fraction 3. You can see that in there. Yeah, okay, well, you know what it should look like. All right, so that's our answer, -4.799. So make sure you study and you understand and you know the difference between x as a base, x as an exponent, raised to the reciprocal power versus log of both sides. Okay, moving on. Number 3. 2.32 equals log of x minus 12.7 all over 1.5. Okay, so this one has a log. If there is a log and there's only one log, there's not a log on each side, you're going to isolate this log. You're going to get it by itself. And you do the stuff you learned back in middle school. You first multiply both sides by the 1.5. Plug that in your calculator. 1.5 times 2.32. You get 3.48 equals log of x minus 12.7. And then your next step is to add the 12.5 to the other side. So go ahead and plug that in your calculator. You should still have the 3.48 in there plus 12.5, and I don't know where I got that 8 from, sorry, plus 12.5. Okay, and I am just all over the place on this one. And I guess that's what I get for trying to multitask. All right. So you still have the decimal in there. Now you're adding 12.7, giving you 16.18 equals log of x. Again, we multiplied both sides by 1.5, got rid of it. That gave us 3.48. We then added the 12.7 to the other side, giving us 16.18. And we're trying to get x, and this is where you either drop the log or wrap around, and since there's not a log on each side, you're going to wrap around, remembering the base is 10, so it's 10 raised to the 16.18 equals x. 10 raised to the 16.18 equals x. Now if you plug this in your calculator, go ahead and try it. It's going to give you this crazy number in scientific notation because it's a really, really big number, so I'm just going to leave it like that. Okay, number 4, e raised to the negative 3x plus 1 equals 7. Now, what is this problem more like? 1, 2, or 3? Look at the x. Is there a log? There's no log, so it's not like this one. Is the x the base or the exponent? It's an exponent, so it's like this one here where I take the log of both sides. But since this is ln, I'm going to take ln of both sides. Ln of e to the negative 3x plus 1 equals ln of 7. And remember, the reason we do that is to bring the exponent down to the front. I'm going to put in parentheses, negative 3x plus 1 times ln of e equals ln of 7. And remembering, we've talked about before, ln of e is simply 1 because the base is e. Ln base or log base e of e is 1. Okay, negative 3x plus 1 equals ln of 7. And ln of 7 is just a decimal in my calculator. So I'm going to subtract 1. Negative 3x equals ln of 7 minus 1. And then I'm going to divide by negative 3. X equals, when you plug this in your calculator, you'll put parentheses, ln of 7, close, this will give you parentheses, close parentheses, minus 1, close parentheses, divided by negative 3. Okay, so let me show you what I'm talking about. Open parentheses, or you could hit equals before dividing if you'd want to. I can't get this in screen. So open parentheses, ln of 7, I'll just type it in and then show you, close parentheses, minus 1, close parentheses, divide by negative 3. Okay, let's see if I can get it in screen. Ln, I open the first parentheses, ln of 7, I close the one it gave me, minus 1, close the one I typed in from the beginning, divide by negative 3. And that gives you negative 0.315. All right, this last one, I'm not going to do it with you. I want you to try it, and we'll talk about it in class. Solve for x in terms of y. Write that down. You have one of these on the test, which is why I'm going over it. And kids struggle with this one. We're still solving, but there's multiple variables. We're going to solve for x in terms of y. Y equals negative 73.5 ln of 1 minus x over 90, close parentheses, and that's it. Okay, so what you're doing here is you're trying to get x by itself, and your answer will have y in it. Solve for x in terms of y. For example, if I solve for y and this is my answer, this would say solve for y in terms of x. But I'm not solving for y, I'm solving for x. So I want to get x by itself. Solve for x in terms of y. Get everything over to the other side, try your best, and we'll talk about it in class. And remember, this is one that kids typically miss on the test, so you want to make sure you give an honest effort and come ready with questions. All right, moving on now to the actual word problems. Okay, compound interest formulas. Two of them. A equals P parentheses 1 plus R over N close parentheses raised to the NT. And the second one is A equals P times E raised to the RT. Okay. You do not have to have these memorized. These will be given to you on the test. But you will need to know what all the little letters stand for. What is A, what is P, what is R, what is N, what is T, what's the difference between the two. When you take money to the bank, they compound it. So every so often they compound it depending on the interest, and you get a little more money every single time. So some banks will compound twice a year. Some banks 3 times a year, 4 times a year. Some will do it monthly. Some will do it bi-monthly. The more it's compounded, the better, because you're going to get a little more money every time. So you want a bank that compounds, you want it to be compounded the most as it possibly can. This one here is compounded continuously, meaning it's nonstop, compounded continuously. So I'm going to write that down, compounded continuously. That's this one here. This one is compounded daily or monthly or weekly, just depending on what it is the bank does. So even though these are given to you, you will need to know what all the little letters stand for and how when to use which formula. Okay, so let's quickly review. P equals R equals, P is the initial amount. R is your rate. T is the time. N is the number of times compounded. Now that's why this has an end and this one does not. Do you notice that? This one has an end because it's compounded, again, weekly, monthly, daily, twice a year, 3 times a year. Compounded, the number of times compounded, that's here. This one doesn't have it because it's compounded continuously. If we actually plugged in values for N and plugged in bigger values for N and bigger values for N, the bigger N gets over time, it eventually ends up being this formula. So that is where it comes from. Okay. A is the amount after time t. Okay, so let's actually try an example. Number 1, $1,000 is invested at 12% compounded quarterly. How long will it take to reach $2,500? Okay, so it's compounded quarterly. Right there, we're using the first formula because we only use this one when it says compounded continuously. It did not use those words, so we're using this one here. 1,000 is our initial investment, our initial amount. So P is 1,000. 12%, our rate is 0.12. T, we don't know, that's what we're looking for. Number of times compounded, quarterly means 4 times a year. And A, the amount after time T, we want to know how long it takes to reach 2,500. All right, so A, 2,500 equals P, 1,000, parentheses, 1 plus 0.12 over N, which is 4, close parentheses, raised to 4, which is N, right there, and then T, we don't know, that's what we're looking for. Ooh, it's a big problem. All right, first thing we're going to do is divide by the 1,000. Gone. 2,500 divided by 1,000 is 2.5. Equals, parentheses, 1 plus, not 1 decimal, 1 plus 0.12 over 4 raised to the 4t. Okay, so what you're going to want to do right now is plug this into your calculator. Go ahead and do that. 1 plus 0.12 divided by 4. And when you're done with it, you can hit pause if you'd like. When you're done with it, it should come out to be 1.03. If you're not getting that, ask me questions about it tomorrow. Raised to the 4t equals 2.5. Okay, think back to the review problems we just went over. What kind of problem is this? Where's the variable? Is the variable the base, or is it the exponent? It's the exponent, and I want to bring it down, so I'm going to take the log of both sides. Log of 2.5, and I'm using base 10, equals log of 1.03 raised to the 4t. And the whole reason we do this is to bring the exponent down to the coefficient so that my variable is no longer an exponent. Log of 2.5, which is a decimal hiding in my calculator, equals 4t times log of 1.03. All right. Divide both sides by log of 1.03. Log of 1.03, leaving behind 4t, and then plug that in your calculator. Log of 2.5, log of 2.5, close parentheses. I'm going to type it in again. Log of 2.5, close parentheses, divide by log of 1.03, and I get 30.9989. I'm not going to round that number. Leave that in your calculator. I'm just going to write it down. I'll put ... to show that I'm not rounding it, because I want to divide both sides by 4 to get t by itself. Divide by 4. So that decimal you still have in your calculator. Divide by 4, and you get 7.749. So t equals 7.750 years once you round to 3 decimal places. So it's going to take a little over 7.5 years to get the investment, 1,000, to end up being 2,500. That's 2.5 times bigger. All right, we're going to try, I'm going to at least set up one more, and we'll finish it in class. Okay, number 2. If $25,000 is invested at 8.5% interest compounded continuously, there's a key word right there. How long is another time question, we're looking for T. How long does it take for the investment to quadruple? And value. Okay, so keyword here is compound continuously, which means we're using what I call the PERT formula. A equals PE raised to the RT. A equals, we'll start with P since we did that earlier. P equals the initial amount you started with, 25,000. E is just a number in your calculator. R equals the rate, 0.085. T is the time, we don't know that. N, we don't need N because there's no N in this formula because it's compounded continuously. The amount after times T, we want to know how long it takes to quadruple. So what is $25,000 quadrupled? That would be 100,000. All right, so plug everything in and solve for T. Same way we did the other one, only this time instead of doing log of both sides, you will be doing ln of both sides. Try it. You should get something really close to 4 years. That's not the exact answer, but it should be really close to 4 years. All right, that is it for this lesson.